Okay. So for this example, sine and cosine intersect infinitely many times in regions that form equal areas. So if we looked at the picture, it basically means the region that they meet up is the same over and over and over and over again. We just want to find one region. So I'll start by putting the sine graph down. Help me get a good picture going. So maybe I'll use 2 for the scale. So sine will look something like this. Okay, and then the cosine graph will look something like this. And I'll connect the dots. Well, certainly not the best cosine. Let's try that again. I know. That's better anyways.
Did YouTube make you nervous?
It's not me that shakes, it's the pen. Okay, so the area that I'm looking for, fortunately for me, like I said, my artistic skills were never the best, but the picture is not, doesn't need to be 100% accurate, but enough that we can see what's happening here. There's one of those regions I'm talking about. So we need to find these bounds again, like we did the last time, right? Right here, what's this point where they cross? What's this point where they cross? So again, it's tough to do this on a graphing calculator because this is going to have lots of decimals. It's going to be some sort of pi value. So again, what we said was, here's how we can do it and be sure, if we don't use the graphing calculator's picture, we can make those two curves equal. So where do they meet? Do you remember where sine and cosine meet? Yeah, that's another way you could think about this. You could also think about it as where tan x equals to 1. Right? And that happens at a couple places. Well, it happens at a lot of places. But pi over 4, which is this piece right here. And then the next time it happens will be at 5 pi over 4, which is going to be up here. Okay, so if you had your, this would be my reference angle, and this would be my 5 pi over 4. Okay. So now that I know the pieces, I can start the bounds for my integral. It's going to go from pi over 4 up to 5 pi over 4. And it's top minus bottom. So which curve is the top?
Sine.
Yeah, the sine x is the top curve here. This one there is the top, which is sine. So it's going to be sine x minus cos x that I integrate. So we can do that. Sine x is going to be negative cos, and cos x is going to be sine. And I'm going to evaluate this at pi over 4 and 5 pi over 4. Okay, so we'll use the calculator again. And again, I made this equal to y1 in my TI-83, and I've got y1 of 5 pi over 4 minus y1 of pi over 4, and I end up with 2.824, sorry, 84. That's just terrible. Let me fix that. 84. And one trick when you're kind of in a rush to find an answer, we could do this exactly, right? These are exact values. We could produce without a calculator, but you know, if we need to produce an exact value here, with the trig stuff, there's so many square roots, like root 3, root 2, that sometimes when you square your answer, you can luck out and it turns out to be nice. So for example, when I square this answer here, if I go like this and I square it, it turns out to be a nice number like 8. So basically that means this answer here is equal to square root 8, and I didn't need to go through all that trouble of exact values. That'll be 2 root 2. So it doesn't always work, but it's worth a try, because if you square